hear me? Yes. Okay, my name is Cristina Ballester. I'm a research engineer, part of the engineering unit at the Spanish National Hydrogen Center. Allow me to introduce you some words about the Centro Nacional del Hidrógeno. This is a research center focused on the development of the hydrogen fuel and fuel cell technologies. It was established in 2007 as a public consortium between the Ministry of Education and Science and the regional government. I'm proud to say that we are the only research center in Spain that covers the entire hydrogen chain value from TRL around 2 up to TRL around 7 or 8. Well, very quickly, this is a sort of timeline of what we have done to conquer the Port of Valencia and enable to install the HRS. With the help of Fundación Valencia Port and the Port Authority, we searched for a perfect location to install the HRS that meets all the requirements of the HRS to be installed. We eventually got the official authorization from the Authority Port of Valencia. To meet all the requirements of the HRS, it was needed to adapt the space. We needed to install grounding grids and equip the foundation, safety walls, and so on. Finally, we got the construction and the commissioning done thanks to our colleagues in the project, Carburos Metálicos. And here it is. This is the hydrogen refueling station. As you can see, there are three main equipment. There's a buffer tank, which houses an average of 50 cubic meters at 40 bars. A compression unit, which elevates the pressure up to 450, and a semi-trailer, which hosts the hydrogen at two different pressure levels, around 300 and 450, and obviously a panel dispenser at the back of the semi-trailer. But how it works here? We have a fixed unit that consists of the buffer tank and the compression unit. This buffer tank is fed by a 200-bar platform supplied by Carburos Metálicos, arrives to the facility, feeds the buffer tank, then that hydrogen we elevate the pressure up to 400 and we store it in a cascade pressure system. Eventually, the semi-trailer goes in and out of the facility to do the performance refueling. But how we do the performance refueling is as it follows. We do the preparation. Our partner, the partner from CVA, do a 360 safety checklist, and when all is done according to the procedure, we are ready to transfer the semi-trailer towards the terminals. The refueling performance takes place in both terminals, and when it's done, the semi-trailer returns to the facility. And if it's needed, we need to start the compression system. All this performance has taken place during 2 years of operation, 2024 and 2025. And according to the plan, this performance needs to be completed before 8 a.m. Regarding the analysis, we can proudly say that we have completed 121 refuelings, 289 days on duty, more than 1,000 kilograms of hydrogen supplied, and obviously we needed to refill the buffer tank with 21 times. If we check and compare between both years, we can say that the number of refuelings have been improved from one year to another. But if you move to the other graph, you say that the time of the HRS in service is slightly less in 2025. That's because the project, as you know, lasted for 7 years, more than we were expecting, and some maintenance needs to be done. So we had to wait for more than we wanted, and we had to stop the performance for a while. But even though we improved the total of hydrogen refuel, having more numbers of refueling, we doubled the numbers. And obviously the buffer tanks that were needed were even more in 2025. Regarding the performance analysis, as you can see here are two graphs representing the refueling performance with our colleagues from H2PORTS. You can see that the refueling time was improved from one year to another. We lasted in the past year around 40 minutes, and we could improve the timing up to 20 minutes without compromising the temperature limits. So we have even more space to improve the refueling time. Bear in mind that in this performance, 2 vehicles needed to be refueled, so the timing of the refueling needed to be as much as optimized that we could do, because the timing of the semi-trailer going to the terminals are what it is, because the terminals we cannot move them, but we can improve the timing of the refueling. So both vehicles were refueled at the exact time, more or less than 1 hour, both of them. And in all the projects that we have worked, we always learn something. In this project, we can learn about the design of the refueling station. We can improve it by connecting straight from the platform to the compressor through the compression system to save time, save money, and optimize the process. And also, if we could connect the platform straight to the cascade system, we can as well improve time, money, and efficiency. The importance of preventive inspection in this hydrogen installation is essential. We have checked and we have proved that having a monthly inspection, checking the connection, checking the instrumentation, and checking the performance, we can avoid unsuccessful refuelings, and we can avoid wasting time for all of us. As a conclusion, as I have said, we have improved the timing of the refueling, we have improved the kilograms of hydrogen that have been refueled, we have improved the efficiency of all the procedures. So for us, the CNHs, we can be proud that the hydrogen technologies is a clear solution and alternative for this maritime sector. You haven't told me of yet, so I think I have the time. So I know these are not the Oscars, but I would like to thank to my team from Puerto Llano that took the time to stay with me here. So Emilio, Diego, Miguel Angel, Bea, Carlos, thanks for having the time with me. I'm being honored that you've been part of this team with me. Thanks to my women team from Carburos and CVA, I couldn't be asked for a better team. So thank you very much. Proudly to say that H2PORTS and the working package 2 that CNEH has developed is a really success. Thank you very much.
Good morning, everybody. I would like to start saying thank you to Fundación Valencia Port for hosting the event and also for coordinating this project, and also to the Clean Hydrogen Partnership for supporting the project. It is an honor for me to represent Carburos Metálicos Air Products Group here and to explain what my team in Carburos Metálicos, Tania Díez, Eva López, Clara Espes, and the rest of the team has done, because without them, I think that the logistics and the operation of the different tests of the project couldn't be done without them. So I think that thanks to you for your efforts in the project. So let me introduce Carburos Metálicos. Carburos Metálicos is an industrial and medical gas company that was founded more than 125 years ago, and in 1995 was acquired by Air Products Group, that is an industrial gas company in US. And we are the leading hydrogen company, production and commercialization of hydrogen worldwide, with the largest pipeline network with more than 1,100 kilometers of pipeline. And we are present in more than 50 countries. Well, so what has been our role in this project, in H2PORTS project, sorry. So we have a pivotal role as a strategic partner for the hydrogen supply and infrastructure, delivering critical technical solutions and operational support. For us, also it was so important to ensure safety, reliability, and efficiency through the project lifecycle. We have participated in this project in 3 different pillars: hydrogen supply via tube trailers, daily hydrogen refueling operation, and technical support and maintenance. I'm going to explain a little bit the different elements in these pillars. So from the hydrogen supply point of view, we have participated in the hydrogen logistics, delivering the hydrogen from the source to here at the port of Valencia with the specialized tube trailers at 200 bar. After this session, we are going to see this equipment. Also, we have participated in the infrastructure. Our team has developed the discharge panel for trailer to installation connection, the pressure regulation panel, and the complete piping and integration with a buffer tank. As Cristina has mentioned before, the total deliveries to the buffer tank was 21, and the immediate hydrogen supply to this buffer was 76 kilos of hydrogen. The second pillar is the daily hydrogen refueling operation. So here the refueling service was aligned with the port personnel. As Cristina mentioned before, this refueling must be done before 8 a.m. This means that our driver starts the day very early, so he has to arrive at 5:25 a.m. every morning from our Sagunto depot to start daily operations. So when the driver arrives to the port of Valencia, then he has to develop the operation procedure, the 360-degree safety checklist before each refueling. Then he disconnects the HRS and from the compressor and transport the mobile part of the HRS to the different terminals to supply first the hydrogen to the ReachStacker and then to the yard tractor. The refueling process is automated, and the driver has to finish all the works before 8 a.m. That is the time when the operation in the port starts. And as mentioned by Cristina, the project outcome is more than 121 refuelings. Last but not least, the technical support and maintenance expertise pillar. We have participated, our team, providing an expert guidance on hydrogen handling safety protocols, leading execution, assembling, testing, and commissioning of hydrogen infrastructure. Also, we have participated to develop the buffer tank installation and commissioning, the inerting process of the HRS, and defining safety distances during HRS construction. Also, something that was so important in the project, the maintenance of the equipment. We are responsible of the preventive and corrective maintenance execution. So, the lessons learned of the project was that we have demonstrated here that the mobile solution to refuel vehicles like this is so relevant when we have small fleets in different terminals. So have a mobile solution that can move from one terminal to the other, enhance the promotion to increase the fleet in every terminal, because install one HRS per terminal, I think is so expensive. So at this moment, so it's something that we should try to avoid at the beginning. And this solution demonstrates that is a good solution without interfering the port logistics. And something that was key for us, and I think that thanks to our knowledge and expertise in hydrogen, we have demonstrated that the need of safety measures and protocols. So do some training and awareness programs where the hydrogen is going to be installed in different applications is key and is critical to have good management of hydrogen solutions. And we have demonstrated that with collaboration of port personnel is something that we can go ahead and demonstrate that hydrogen is a good solution in any port, airport, or any relevant area like this. And finally, some environmental considerations. I think that we have demonstrated that hydrogen and fuel cell technologies are particularly suited to these environments, offering an effective pathway for decarbonizing this sector. So, thanks to the project, we are demonstrating that the hydrogen is a real solution in port environments, that we can reduce emissions, and with this kind of solutions, we can adapt the different complexities that we find in ports. So thank you all for your attention.
Okay. Thank you very much, Esperanza and Cristina. As you can imagine, we are talking about real machines. Without them, it's impossible to provide hydrogen to the machines. We have 3 minutes for questions, if you want. There is a possibility to have questions. If not, I will go to the next panel. Any question from there? No, pues thank you very much, Cristina and Esperanza. And now, let's go to the next panel. Okay. Now we are in a scenario that we have the hydrogen in the port, we have the HRS ready, we are waking up very, very early in the morning. We did a lot of tests during the project. We wake up at 4 o'clock in the morning in order to be here in the port. And the driver comes to Valencia, takes the trailer and takes the HRS and visit one terminal. And now it's time to visit the first terminal. It's from Mediterranean Shipping Company, Terminal Valencia. And for that, there is a pilot there. And the pilot is managed by H2PORTS in this case. So it's an honor for me to introduce Jost Hoosdoen. He's a vehicle integration leader of H2PORTS, who has done very huge work building the first ReachStacker in the world proper by hydrogen. So, Jost, the floor is yours.
Yes, thank you. So, thank you, welcome all. My name is Joost Hoogduin, vehicle integration leader, and I'm going to tell you a bit about our experience and results about implementing fuel cells and hydrogen technology in real-world port equipment. I will do a short introduction about the company ourselves, H2PORTS. Next to that, I will deliver an overview of the ReachStacker. We will also see it in real life later on this evening or afternoon. Then I'm going to talk about a bit the performance analysis that we've done on the truck, because it actually operated in a real port equipment or a real port environment. The fourth part is the lessons learned, and the last part is the conclusion. So to start off with, H2PORTS has a vision which is transforming the way the world moves materials from port to home. So to cover the whole line from the port towards the home. To do so, we have our mission, which is built out of 2 parts. One is to provide optimal solutions, and we do that to meet all the specific requirements that material handling has. And next to that, we have exceptional customer care. For us, the customer always comes first, and we never let our customer down. An example of that is also the hypercare team that we set up. And that's a specific team dedicated to keeping our new technology trucks, electric trucks, hydrogen trucks, running in the field with direct support. Then a bit of explanation that some people might not immediately grasp, but lift trucks are an integral part of the supply chain in our lives at the moment. If you take the example of your shirt that you're wearing, it's most probably touched by 23 forklift movements, getting it from a container into a warehouse, into another warehouse. You don't think about that when you just buy your shirt at the shop, but 23 forklift movements have touched that. In a similar way, if you're renovating or working on the house, the lumber that you need, it has 14 forklift movements to just get it to your house. And that's why lift trucks are integrally a part of the supply chain of our lives at the moment. Then our company, we have a global coverage. We are spread on 5 continents. We have 11 development and test centers, from Nijmegen to Italy to Greenville to China. We have 8 manufacturing plants, and we are a dealer-supported organization. So we have over 250 dealers, of which a few also joined today. Then the product line, as you can see, we don't only do big trucks, we do everything from the smallest to the biggest forklift. We do electric, small class 1, 2 and 3 trucks. We do ICE trucks, counterbalanced ones for in warehouses, for example. And of course, as you might recognize, we do the big trucks. They are all produced in Nijmegen, and they go from 8 to 52 tons of lifting capacity. And we don't only have them in internal combustion, but right now we are also developing the fuel cell and battery technology for those big trucks. Next to the lift trucks that we deliver, we have a few pillars in technologies and power, which are being the automation, the operator assist systems that we develop in-house, and the telematics that come with that, and also the power options. As we are here presenting it, we had for ages ICE diesel engines. Right now we're adding to that with batteries and with hydrogen fuel cell systems. Then going to the real big truck development that I'm about to share you today. We started with building full battery electric lithium-ion trucks. They have a battery pack, and we have several voltage levels for them, for the smaller trucks and the big trucks. But next to that, we also developed our fuel cell hybrid line. And we are developing that also on several different trucks. With that, we aim to lessen the impact of material handling and movement on people, the environment, the economy. And we do that by the creativity and the imagination of our teams. I'm being part of one of those teams. We're developing new technology on existing trucks. Then the project. Starting the project 7 years ago, we had 3 main goals. The first one being the training and acceptance of the hydrogen fuel cell ReachStacker to the port operators. A very important part, as already mentioned by the rest of the group as well. The next step was deploying the actual ReachStacker in normal operation at the MSC terminal in Valencia. The third one is to collect data and to confirm and improve if the design that we made had any improvements for future designs. To give you an overview, and this afternoon it will be even more and a better overview because we will see the truck in real life, but the basic figures are that we have an electric motor to provide traction. It's a 220 kilowatt e-motor. Then we have 2 motors for the hydraulic performance. We need 2 to be able to lift the 52 tons capacity that we have. Then more interesting for this group, 2 times a 45 kilowatt Nuvera fuel cell. We have a single battery pack in the back that acts as a buffer, because we cannot operate a fuel cell without a battery. So for that we have a single pack, 130 kilowatt hours at 675 volts battery pack, and we have a hydrogen storage. So it's a 32 kilogram hydrogen storage. It's a single module consisting out of 4 tanks. It includes the hydrogen refueling panel, and it includes all the plumbing and all the hoses and connections within. It's mounted on the right hand side of the truck, and with that we are able to confirm and to reach the most basic truck requirements that were set for this project, being ICE-like performance, so acceleration, capacity and duration of it, hydrogen refueling in under 30 minutes, then full shift operation on a single refuel, single tank, and improved handling and productivity. After starting the project, we became clear quite soon that I can show you this graph of KPIs. We can focus on hydrogen consumption, average moves per hour. But what you could see quite quickly is that performance-wise, we were able to meet all the requirements. The truck was built according to the requirements, it was performing. But performance, or looking at KPIs, is not the most interesting or important thing with regards to this project. Because we are not the only ones in this project. So yes, maybe the truck will perform, but to perform, we need hydrogen, we need operation, we need all kinds of partners. They all need to align. So looking at these values, hydrogen consumption, for us, it's relatively low. The explanation on it is that we had a lot of testing. We had quite some idle time in between to get stuff fixed on the truck or to get stuff coordinated with partners. Also the movements per hour, if you look over the overall KPIs, this is the list of the whole project, so the conclusion of everything. It's not that much, but if you zoom in into, for example, a single month, we go over 15 moves per hour, which is almost double of the value in this average KPI. Then an important one, and one that we indeed ticked off relatively soon after the improvements that we made together with our partners, is, for example, the refueling time. That's actually a KPI that we can say we reached that, and we're proud of that as well. In total, what you also see, and where we deviate from the values of other partners, is the hydrogen consumption and, for example, the amount of refuelings. Because we not only count the daily refuelings, we also had to do calibration refuelings. At the beginning of the project, we need a lot of alignment. Every time when we add a bit of hydrogen, we see that as a refueling. Hence, we have a higher count in refuelings. Then, to me, a more interesting graph is the following. It's the accumulation of hours over the project. And what you can see is that we have several parts where we have a steep incline, but we also have several parts where we have a flat line. And on those flat lines, that's where we had our lessons learned for this project. So to begin with, at the start of the project, we had several challenges that caused us to not being in operation right away as expected. We had a charger issue, it's infrastructure related. But in the end, you need it to be able to start up the truck, which means the first flat line. Then second one was also an experience where we learned a lot of, which is having a dual fuel cell setup. It has its advantages, but also its disadvantages. One of being the isolation that we had. So that's the high voltage isolation on the fuel cell. But also there we managed to find our way out of it in updating the architecture of the fuel cell, and in that sense still making the truck provide performance as expected. Then towards the end, we had contamination in hydrogen. So what we figured out after a while is that we saw a degrading performance in the fuel cell. We could see that in the telemetry, we could see it coming in that sense. Also one of the lessons learned, that we improved our dashboards in telemetry to preventatively see what's happening on the truck. This one, the lessons learned was mainly that we have to work with our partners, because we were not sure about the issue. Our hydrogen supplier companies were not sure. And in the end, it's not only 2 steps to fill a hydrogen truck, but there are multiple. It's filling the buffer tank, it's filling the compressor, it's filling the mobile refueler, it can be the filling hose in between. There was somewhere contamination, and in the end, as partners within the project, we managed to find or locate the root cause of it and solved it relatively quickly. And the last one, towards the end of the project, where we faced an issue with one of our hydrogen hoses in combination with the refueling that we've done. We saw some drops in the protocols, in the safety protocols that are there for a reason, which focused or pointed us at the challenge of a flexible hose in our system. We replaced the hose, we used a hypercare support team for that, and all our partners to be able to test with nitrogen. It was always a pleasure, or is a pleasure, to work with all the partners. Then on the top side of the graph, because we also had some steep inclines, at the start we manually coordinated all the refueling. It was between engineers, with other engineers. We had people on site who were there manually controlling the refueling at the start. As the next phase, we transferred part of that towards MSC, our customer, our partner in this project, who operate the truck and who aligned on the daily planned refuelings. So if we had the refueling or needed the refueling, they did that on themselves. So no direct engineering involvement required anymore. And the next step there was automatically, for almost 2.5 months, we did full-time daily refueling, daily updates, daily charging, which all worked pretty fine. And I think we can all be really proud on that step, that we actually proven that it's not something laboratory-wise or prototype-wise, but it's actually taking the next step in development. Then, to me, one of the most important things, it's also the first goal of the project, is operator acceptance. To capture that, we conducted several questionnaires among the dockers, the actual drivers of the truck, and we captured feedback of that. We focused on comparison, whatever future wish they would like to have, and what's the reason why they would like to have the wish. And in the end, of course, final rating. First one, comparison, acceptable. It's similar to a diesel. Future wish, I actually really like this feedback. It's not about acceptance, it's not about hydrogen, it's not about electric trucks. They are looking into a zeroing button on the spreader. To me, that shows that the rest of the truck is accepted, because they are already focusing on details like a spreader. Next point of feedback, comparing to other trucks that they're used to, the truck has better stability, and the future wish there is more hydrogen, a longer hydrogen charge, so more hydrogen to be able to do more shifts without refueling. Because we also know that we have to do the refueling between 6 and 8 in the morning. So the more hydrogen we have on board, the easier it gets to run, for example, a dual shift operation. Then the next one, it's a very powerful machine, and the future wish there as well, longer operation with faster recharges and a bit more speed and comfort. But main reason, it works already well, and all the tasks are done comfortably. Then the last one, when it works, it has a lot of power, it's more stable, intuitive and easy controls. It's well designed and it has the stability and power necessary. To me, the first part of the sentence is an interesting one, and it's the link to the next slide for me. Part of the lessons learned, when it works. In that, it doesn't always show that the truck isn't working or one step is not working. But what it shows is that having complex machines and operations like the hydrogen fuel cell ReachStacker, being a truck with hydrogen, with batteries, with a mobile refueler, with a buffer, and with operators, you have multiple factors and multiple teams that are new. the technology is new for everyone. So we all have our challenges, but those challenges never align in time. We don't have a challenge at the same moment. We always have it sequential. So what I will try to show here is that if you look at it quarter per quarter, you'll see the first step, we were working with the HRS to get compliance. The truck was there, the buffer was there, the operators were happy. Second step, after fixing the HRS, we conquered our first challenge on our truck, which means the truck was a red bullet, but the HRS was fine, the buffer was fine, and the operation was fine. In the end, what you'll see over the whole period, if you look at it quarter per quarter, you almost never have operation, mainly due to the reason it always comes in phases. However, if you zoom in, not into a quarter, but into a month, for example, and that's also what you see in the first graph that I've shown, if everything aligns well, we will have operation, and it will be for a longer period. So we have seen several months, not 1 month, but also 2.5 months in a row, where we did have operation for a longer period without any issues. And that's, to me, a lessons learned, that at the moment, with all the new technology, I compare this to a domino day. And part of the domino is the fuel cell system. The second part can be the truck. There's a charging infrastructure, there's a mobile refueler, there's operator acceptance, and there's operators themselves. They also have holidays or acceptance, or there are issues. With that, operation is always the final stone. So no matter what issue occurs, along the whole domino, there's always operation that faces the end, that a truck is not operational, or they cannot move their materials. Having that said, to me, my main lesson learned is that by collaborating with the customers, with the suppliers, with dealers, with operations in a new way, we will together have to build the solid foundation that does not fall. So as shown on the picture, we will have to become, with all of our partners, that final stone that's strong enough to prevent that operation will fall. We'll have to find our ways in that. Coming to the conclusion, we set the main project goals at the beginning, training and acceptance of the fuel cell ReachStacker. With the feedback we got, I would say that's definitely a yes. Deploying it in normal operation at MSC terminal, yes, we had a lot of support of MSC. They were always willing and are always willing to support us in every way, in every opportunity, where we need a recharge, where we need some extra tests done. We have our hypercare team online. Sometimes we want to do something locally. They were always willing to support, to also be able to operate the truck as soon as possible. Collect data, confirm the improvement of the design. That's also a yes. And I'm actually really proud to show the next picture, which is the next generation of zero emissions equipment. It's built already. We're testing that right now at Weeze, our test facility. But it shows the commitment that we as a company have. But it also shows that the lessons we've learned during this project are implemented, and that we added them to the design of the new trucks that we are right now testing. And that show that hydrogen, yes, it's a real opportunity, and it's a possibility for future port equipment. That's it.
Thank you very much. Just, it was impressive. Also, take into account that it was very complex also from the point of view of the port terminal operator. We have to say that the MSC, Terminal Valencia, did a very good job. They adapted the facility, the terminal, going with the protocols and also the risk prevention for the port workers in this case, and dockers. And also here we have Centro Portuario de Empleo de Valencia, that they did a very good job as well. We could introduce the concept of hydrogen to this important player in the port, the stevedores, and it was very fruitful to learn with them to explain what is hydrogen and how the machine is working. And I have to say also that H2PORTS put all the efforts from all over the world to have this machine in the Port Valencia. It's the first time in the world. This is one comment that is very important. I don't know if you are thinking in another model. And the first model in, for example, a Ferrari or a new model in BMW, whatever, is the first model. So all the issues that you overcome during the project, it's a normal situation. It's a normal situation.
We learned a lot.
We are very happy to see that there is a continuation in the units, and congratulations for the work. This is my first thought on that. Okay, and a big applause to them. And now we are saving time. You can leave your belongings there, and let's go to the coffee break. But you have to come back at 11 o'clock sharp, because we will continue with the presentation of Athena. Okay, thank you very much. 30 minutes. 11 o'clock here. Thank you.